There you go. All right, for today, this is the first day on trig, and we're going to be doing mostly trig ratios. These access codes are not correct. We've got you already in Schoology, which you probably know already. If you have issues with that, please just send me a quick email, and I'll be happy to get you in the right Schoology class. Let's go over here. Basically, the main things you ought to do in this class, just get your homework done. One of the things that people have had different experiences with in first semester is some of you guys had a different teacher in first semester and they didn't actually grade the homework. I do, not every day, but I do randomly, and I do put it in the grade book. What does that mean for you? That means basically if you don't do your homework, you won't get as good a grade in here. I don't throw out the formative category, because anybody who's got half of brain realizes if they're going to throw out the formative category, then the homework doesn't matter. Why should I ever do it? If you ever got a choice between this and something else that matters, you'll do the other thing. So I need you to do your homework. I also understand being a kid that's got too much homework to do, so I keep it really short. You'll find that I only assign a subset of the homework. Like I'll say this problem, that problem, and that problem, maybe 4 questions. Okay, it's very doable, but you need to do it at night, because that's, brain research says, touching it that one extra time in 24 hours makes a dramatic difference in how well you're going to remember it. Otherwise, you're just wasting your time. All right, so do your homework. Next thing, be respectful. If there's just one thing that helps the most, it's just to be respectful. Don't have your cell phone out. I know this is something I should probably bring up right now. There's a few cell phones that are out. Just put them away at the beginning of class. I won't yell at you if you have your cell phone out, but I will ask you to put it away. And if you have it out from now on, now that I've kind of given you a heads up, if you keep on putting it out, then I'll take it away and put it on my desk, and then you could take it back at the end of the hour. Just don't have it out. Last 10 minutes, I don't have a problem with the cell phone being out, but not at the beginning. Question? Do you have like work time for homework? Yes, in the last 10 minutes, when it gets to the work time, you absolutely can bust your phones out. You can listen to music on them, no problem. Can't have your headphones in while I'm teaching though. Okay, because I think you understand the difference between those two things. Like if I have my headphones out and put them in during a meeting with the principal, do you get how you might have an issue with that? Okay. Do you get though, once we're done with our meeting and I'm in my work time and I put my headphones in, I mean, that's pretty understandable. Everybody gets that. All right. So during the last 10 minutes is kind of your time. You can work on other stuff, and I won't hassle you in the last 10. All right. And one change to this: it's not Tuesday, Wednesday, Mass, and Thursday. It's Monday. It's Monday, Wednesday during Mass, and Thursday that I have available time. I do have a welcome page. This group of kids recommended, here's how you should do your Schoology different. So I improved my Schoology with a welcome folder that's got my hours in it. Right there you'd be able to find where's my email, where's my hours, and I made that better so you can know exactly when my hours are. If you're ever like, dang, does he have office hours tomorrow? Look at my welcome folder. Okay? All right, moving on. Trigonometric ratios. If I asked you to do this, I think that from my judging from last hour, I don't think anybody could do it. Like none of you. And that's okay, but we just have to start where we are, which was probably, some of you remember SOHCAHTOA. Does that SOHCAHTOA ring a bell? All right, I'm going to start by, and you're going to need to add a page or something to do because there's a lot of catch up. SOHCAHTOA. SOHCAHTOA. What does that mean, Mr. Server? Well, you'd have to understand what the O and the H and the A mean. This means sine, this means cosine, and this means tangent. But what in the world do O and H and A mean? Well, first of all, I got to start with that. So here's a triangle, here's an angle, and the side that's across from it is the opposite side. Do you get if I was on a different angle, then one of the other sides would be opposite? Okay, so this changes depending on which angle you're talking about. I'm doing this angle right here. The opposite side and the adjacent side are always not the hypotenuse, right? They're the other two legs. The hypotenuse is the longest side. It's across from the right angle. Think about it. The biggest angle has the biggest side across from it. Doesn't that make sense? It's open the widest. Okay, so this is the hypotenuse. So when I say, what is the sine of this angle? You're going to have to know what that means. So I'm going to give you the most basic, easy, right triangle trig problem that they could put on the ACT. I tend to be a little obsessed with the ACT because I know how important it is going to be for you. The biggest math test you'll ever take. Why shouldn't I get you ready for it? Okay, so here's a typical one. You guys all know that there's a 3, 4, 5 triangle, right? So let's write in the sides. 3 here on the short side, 4 on the medium side, and 5 on the long side. How could I prove that that's true? Because a squared plus b squared equals c squared. And what's 3 squared? 9. 4 squared? 16. 5 squared? 25. Do you get that 9 and 16 adds at 25? Okay, so then here's the question. If I pick one of these angles, it really doesn't matter which one I pick. I'm just going to pick one. Here's one thing, though. Don't ever pick the 90, because you can't do sine of 90 or cosine of 90 or tangent of 90 yet. You'll learn that later this year. But if I pick this angle right here, now that I've reviewed what opposite and hypotenuse and adjacent are, would you please figure out what cosine of that angle, I'm going to call it theta. What's cosine of theta? Pausing. So I just asked a second ago, like, how many people were positive that they had this right? And I totally get, you are totally fresh and new at trig. It's like you never learned it. There's only 3 people that raised their hand and said they were positive they got this right. And you'll look back on this and go, oh my gosh, I didn't even know how to find sine of an angle or cosine of an angle. Because now you're going to be doing something that is so much more complicated than this. But it all bases on this. So this is super important. It's kind of like when you learn to add. Do you still add today? If you'd screwed that up, if you didn't know how to add, there's no way you'd have made it to this class. You can't do this class without basic adding. I mean, it's like, duh. Same thing with trig. You can't do high-level trig without understanding what sine, cosine, and tangent are. All right, so this is so critical. Just learn it really well. It's like you're learning adding. And you don't want to screw that up because it'll really haunt you later. All right, cosine is adjacent. What's the adjacent side to this one? The 4 is the adjacent. Cosine, adjacent over hypotenuse. And what is the adjacent side? 4. What's the hypotenuse side? 5, and therefore it's 4/5. And I know a lot of you had it, but you weren't confident in it. All right, now that you saw that one, I bet you'll be much more confident in this next one. What's the sine of theta? Don't say it, write it. And in a moment, I'm going to have you check with the kid next to you, and I want you to get to know their name. So I'm going to have you introduce yourself and say one thing about you that they can know. Like, you don't have to tell them your deepest, darkest secret of what you did last summer. But at least you need to tell them something like, I like soccer, or something light, okay? If you want to get deep and talk about the metaphysical, fine with me. But at least you need to know that one person's name and something about them like, oh, she's a hockey player. All right, I'm going to pause for a second while you introduce yourself. I'm going to show you who. Okay, so kids have introduced themselves to each other, and they have also checked to see if the other person had the same thing. Sine is opposite over hypotenuse, so it's 3 over 5. And then last but not least is tangent. TOA. Opposite over adjacent. If you want to make a little helper thing for yourself next to it, that's fine. But we don't actually leave O and A there. Opposite is 3. Adjacent is 4. Tangent of theta is 3/4. Okay, raise your hand if you had that one right. All right, so that's the basics. Is that everything? No, that's just the basics. That's like you teaching a little kid to play hockey and you say, here's the net and here's a puck, and you're trying to get the puck in the net. It's like, is there more to hockey? Yeah, there's a lot more to it. Is there more to trig? Oh, there's a lot more to trig, okay? But if you don't get this part right, if you don't get that the puck goes in the net, then you're going to have a problem, okay? So we got to get this down. All right, so let's talk about some right triangles that you ought to know. Like you've seen them before, but they may have slipped your mind. And there is a couple slides on this one that I like. Right here. Let's find this slide. I don't have to remake the wheel for everything. There's quite a few slides that are not good on this one, but this one's a good one. Can you fill in the little white boxes? You knew these at one point. Those are like numbers like 1 and 3 and 7 and 2 and square root of 2 and that kind of stuff. Fill in those little boxes if you remember, and if you don't remember them, these are going to become like second nature. You've got to know these just as much as you got to know 6 times 3 is 18. You got to be able to do these right triangles. Who had 1 and 1 and root 2? Remember that? It's about half the class there. If you didn't have that memorized, write that down and memorize it. You got to know these. Now, how could you know that? Well, think about it. What's across from the 45 is going to be the same as what's across from this 45 because the ratio of the angle and the side kind of go together. The biggest angles go across from the biggest sides. And if these sides are across from 45s, they got to be the same. All right. And then, how do you know that they're ones, though? Couldn't they have been something else? Not if there's a square root of 2 here, because this squared, which is 1, and this squared, which is 1, has to equal this squared. And the square root of 2 squared is the square root of 4, which is 2. So, get if I square this one, I get 1. If I square this one, and then I get 1. If I square that one, I get 2, and 1 plus 1 makes 2. All right. Now, this other one, 1, 2, and square root of 3 is the things that go together. But what goes where? Think about it logically. What's the smallest side in 1, 2, and square root 3? What's the smallest side there? 1, and that has to go across from the smallest angle, which is the 30. So this is a 1. This is a 2, and this one's square root of 3. I like to say that one's as easy as 1, 2, 3, except it's not quite that easy, right? Because it's not actually a 3, it's a square root of 3. How can I prove this is right if your friend was like, no, I think it's something else? That squared have to add up to that squared. 2 squared, 4. 1 squared, 1. 4 and 1 makes 5. And that's the square root of 5. What? No. You take the square root, take this squared. Square root of 3 is 3. It's 3 plus 1 makes 4. All right, I know that marker was terrible. I'm going to switch colors and see if you've really got this. I'm going to make the triangle look different. That's 30. That's 60. Would you please write in the correct sides? It's as easy as 1, 2, 3, sort of. What has to be across from the 30? The 1. The smallest side, smallest angles. What's across from the 90? Well, the biggest side. In 1, 2, square root 3. It's tempting to think the square root of 3 is the biggest one, but it's not. 2 is the biggest one, and this is the square root of 3. All right, if I had to, if my life depended on it, I would double check it, and I go 1 squared, root 3 squared, which is root 3 times root 3, which is root 9, which is 3. So that turns into 3. That turns into 1. And that turns into 4, 1 squared, 1, 3, and they add up to 4. Yay. That's the a squared, b squared, c squared thing. All right. Now, I need to also make sure that when the numbers aren't ones you're supposed to have memorized, like if I say, okay, here's a triangle, and this side is 3 and this side is 7, is that one you automatically know? No. But you have to be good at finding that third side in a right triangle. This is super handy. I know you can do a squared plus b squared equals c squared, but that takes forever. So try to hang with me here You're in an honors class. You're supposed to be able to go fast. And honestly, I hate to break it to you, second semester's harder than first semester. You're going to have to try a little harder to keep an A going if you want the A. If you had a B last semester and you want that same B, you're going to have to work a little harder than you did last semester. It's just a little harder. It is. Everybody will tell you that second semester with the trig in it, it's a little harder. All right, so stay with me. Take notes, keep trying, and you'll be okay. Do your homework. That's part of the keep trying. This side is the square root of 49 plus 9. See how fast that was? Square root of 58. How to get that? That's squared. That's squared. And since it's the longest side, because it's the hypotenuse, I add them. If it wasn't the longest side, I would have subtracted them. I'm going to see if you caught that. I'm going to do it again. I'm going to make this triangle have a side of 4 and 7, and this third side, would you figure it out, please? 4, 7, and square root of something. Who realized it was 49 and 16? Raise your hand if you had that. That's awesome. Is it a plus or a minus inside? It's a plus because isn't this the longest side? So you should add them together, and that'll make the biggest number it can, right? All right. So that makes what? Well, I'm going to borrow 1 from the 16 to add to that, and that makes it 50 plus 15, which would be 65. Square root of 65. Okay. One more like that. Just you really need to be fast at finding the third side of a triangle. Why? Because we use right triangles all the time. And if I give you 2 sides of it, you got to be able to be just automatic with finding the other one. So what if it's not the hypotenuse? What if this is 8 and this is 9 and I don't know that? Well, it's still square root of. If this is the right angle. I already mentioned it once, but we haven't practiced it. Give it a shot, and hint, it's going to involve 81 and 64. I know you can figure it out the long way, but trust me, that would be kind of like you using long division by hand when you had a calculator. The calculator is so much easier to do long division, right? This is so much easier than writing out a squared plus b squared equals c squared and solving it. That's going to be too slow, unless you want to take an hour to do your homework at night. All right, compare your answer, square root of something, to the kid next to you. And if you don't understand, say, can you help me? All right, it was definitely 81 and 64, but should you add them this time? No, you subtract them. So square root of 81 minus 64. Which is the square root of what? 17? Raise your hand if you had the square root of 17. Awesome. Why would you need that? Because imagine for a moment I had said, what is the sine of that angle? Well, I'd write sine of theta is the opposite over the hypotenuse. Do you get I needed that side to be able to figure out what to put for opposite? So opposite is square root of 17 over hypotenuse is 9. There we go. Square root of 17 over 9. That's why you need that third side. That's why you need to be able to do it fast. All right, so let me give you another one. Make a triangle like this. We're going to say this is 4. And this one's 6. And I don't know what that one is. But here's the question. What's the sine of theta? But you didn't tell us what the opposite is. Well, figure it out. I'm going to pause for a second while you give that one a try. Okay, so hopefully you said, oh, I think I got this. He said to put square root of, and I got 36, and here'd be a common mistake. 36 plus 16. Why don't I add them? Because it's not the longest side. So I subtract them. What is 36 minus 16? Square root of 20. And some smarty pantses probably said that's the square root of 4 and the square root of 5, so it's 2 root 5. Yay for you. But if you got this far, at least, I'm proud of you. Square root of 20. How many of you at least got the square root of 20? Okay, awesome. I'm curious how many people actually did simplify to 2 root 5. All right, that's only 3 people. But You all should do that eventually. Okay, so then if it's square root of 20, then what is sine? Square root of 20 over hypotenuse 6. There you go. Okay, now here's where it all comes together into the problems that you have for homework for tonight. And it goes something like this. You get a problem, and it's one of those classic triangles. It's a 30, 60, 90. And I'm going to say that this one's 30, this one's 60, and this one's 90. One thing that's important, you can't look at this and say, but Mr. Server, I think you actually drew that as 68 degrees. It's not 60. Okay, you don't want to look at the angles that close. You want to draw your triangles in a kind of nebulous way. Do you get, I could have labeled that with a 45, 45, 90, and I kind of could have got away with that? I mean, now that I said it's a 30, 60, you might think, oh, it's got to be a 30, 60. But do you get if I'd have said this was 45, 45, 90? You'd have to trust the numbers, not the drawing. That's true for your test. That's true for your homework. Trust the numbers, not the drawing. Even the ACT says that. The ACT says, do not trust that these angles are perfect. You can't trust, the drawings are not to scale. That's to cover themselves legally. Can you imagine if there was a printing error on the test and it was actually 41 degrees and instead of 45? Some lawyer would seriously be like, you jeopardized my child's chance at Harvard because it said it was actually 41, it wasn't 45. They'll say right on the drawing, not to scale. Okay, so same thing's going to happen on your homework. Trust the numbers they write. Okay, so back to 30, 60, 90. Trust the numbers. And what if I say this side is 17? That's not one of the classics. Well, then here's my best advice on how to do this. Everybody draw in the helper triangle next to it. First of all, draw it about the same proportions and in the same orientation. Don't like flip it around, make it backwards. I usually like it when these are standing on their head. Draw them the same way as the original. And then label them 30, 60, 90. And then last but not least, put in the side ratios that you know. 1. The hypotenuse is across from the biggest angle, and that's the 90, and that's the biggest side, which is 1, 2, square root of 3. Now, let's see how fast you learn. You need to be a fast learner in honors pre-calc, okay? If I wanted this side, I'm going to call it x. Here's your proportion. X is to 2 like 17 is to 1. See what I did there? I started with the variable. I said, what's this like? Well, it's like that. In the same ratio as 17 is to 1. Now, at this point, usually there's somebody who says, and you can cross multiply. That's true. You can cross multiply when you have two fractions that are set equal, but there's a faster way. If you always start with the variable, then you'll just have to times by the denominator. Do you remember the whole clear your fractions deal from first semester? There was a lot of clearing fractions. Look at fractions cleared. X is alone, 17 times 2. I'm done. Did I have to set up a proportion and write this times this equals that times that and then solve it? Nope. Just had to do one step. And the final answer was x equals, and whatever double 17 is, 34. So what was the process there? I drew the helper triangle next to it. You got to only know two of them. The 30, 60, 90, 45, 45, 90. See why those are important? Those are not given to you on the test. So imagine the test question. This could be an ACT or your next test question. I'm going to assume this time it's a 45, 45, 90. Like I said, draw your triangles sort of nebulous. If you draw them really long and skinny like this and then you try to say that's a 45, people will be like, no, that's a 30, 60, 90. So don't draw it long and skinny. Draw them kind of where you can't tell what their angles are. Make it kind of a short, fat triangle, and then just trust your labels. You're going to draw a lot of triangles. That's why I'm taking the time to tell you how to draw a triangle. Never draw long, skinny ones. Draw them short and fat, and trust the labels. Okay, so this could have passed for 30, 60, 90, but it's actually 45, 45. And I'm going to say this side right here is not the square root of 2 like you'd like it to be. It's going to be the square root of 7. Ew. Well then, make the helper triangle right next to it. the same orientation with the classic side ratios. And let's solve for this side here. I'm going to call it Q. I don't want you to think it's always X. It could be any letter. Solve for Q. Some of you already have it. I'm going to pause for a second, see if you've got it. Solve for Q. You should have said this was a 1, 1, and a square root of 2. First of all, how many of you had that memorized already? Awesome. If you didn't know it before, yeah, it seems like you know it now. Now, how many of you started with a Q and then did your proportion thing? All right, good. Finish it off from there. I'm going to pause for a second until you get the final answer. Q is equal to Q over something is equal to something over something. So let's see. You should have said Q is to 1 like root 7 is to root 2. And do I have to really multiply by 1 on both sides? No, that's just Q. Q is root 7 over root 2. Raise your hand if you had root 7 over root 2. Y'all had it right. Nobody was confident. Well, one person was confident. Okay, so this next one is going to be just like that, except this time I want you to turn your iPad my way and really circle your answer and then zoom in on it like this when I ask you to turn it my way, and I'll tell you quick with a turn of the iPad whether you did it right or not. Okay, so here's your kind of your last question to see if you got this. Remember to trust. I'm going to on purpose make this triangle not great. Remember to trust the numbers, not what I say the angles are. Let's say that this side is 40. Would you please figure out how long y is? This is a 45, 45, 90 triangle, and the hypotenuse is 40. What's that bottom side, the y? I'll pause for a second while you give it a try, and then when you're ready, turn your iPad my way, and we'll see what you got. So, from my estimation here, most people had this. It was y goes with 1, like 40 goes with root 2. Now, I want you to think about this answer. 40 root 2 over 2. If I saw that, I would go, dang, that kid is smart. Can you see what they did? To get from here to here? What'd they do? And why would multiplying by root 2 be like a smart thing to do right here? You end up with square root of 4, which is 2, and you end up with 40 root 2. Why is this good? Because that one's been rationalized. That means that the denominator doesn't have a square root in it anymore, and that's going to happen a lot this semester. You need to know that you're technically not supposed to leave square roots in the denominator. Not saying it's going to happen every time. I don't require it because the AP test doesn't require it. AP Calculus has this in it, and they don't require rationalization according to what our high school teachers that teach AP Calc say, so they don't make kids rationalize. But a lot of the problems are written that way, and a lot of the answers in the answer keys are written that way. So it's good to know that you can multiply by a square root like this to clear that square root out of the denominator. All right, so one last one. Can you put your bag down? I have a feeling I know what you're doing. All right, would you please answer this one for me? Long, skinny. But I'm going to say this is 30 and this is 60. And isn't that annoying? But you got to trust the numbers, not the drawing. I know, it doesn't look right, but trust the numbers. And let's say this side is 17, and I want to know L. Solve. This time, instead of showing me, when you're done, just acknowledge to your partner that the person sitting next to you that I'm ready when you're ready kind of thing, you know? Like compare when you both got it. Now be careful, because I on purpose labeled these where they seem like they might want to be reversed, the 30 and the 60, but you got to trust the numbers, not the drawing. So what's in the classic 30, 60, 90? This is a 1 and a 2 and a square root of 3. If you didn't label that right, remember the 30 goes across from the smallest side is the 1, so the 30 goes with the 1. The 2 is always the hypotenuse. Did you ever notice that on the other one, 45, 45, 90, the other one's also a 2, but it's a root 2? The hypotenuses are both 2's. It's just one of them's a root 2. If you ever get confused between the two triangles, try to remember that the hypotenuses are both 2. One of them's a regular 2, one of them's a square root of 2. Okay, so that was just a side note. Did you say L over 2 equals, and I got to go back and forth, 17 over 1, multiply both sides by 2. Oh, we had this one before. Raise your hand if you had 34. Okay, awesome. It was a different looking triangle, but we ended up with that 17 in the same spot, relatively speaking. Okay, so what else is there? There's only one other topic, and that's this. If I said what's sine of 30, you might think you'd need a calculator to do that, but you don't. Draw the helper triangle. Figure out what sine of 30 is. That's one of the reasons these are so good to memorize. They're worth memorizing. Now, since I didn't say how the triangle looked, you got kind of free form. You can do it any way you want. Like draw it upside down, backwards from mine, doesn't matter. But you should label the angle across from the 30, or the side across from the 30 gets a 1, this gets a 2, and this gets a square root of 3. Hypotenuses are always 2's, right? Either 2 or square root of 2. And sine of this angle is opposite over hypotenuse is 1/2. Raise your hand if you had 1/2. Awesome. That's going to be the first time that shows up. Sine of 30 is 1/2. I'm going to take a bet right now that this will show up at least 10 times between now and the end of trig. That it's going to come up that, oh, it's sine of 30. Just memorize it. It's like, what's 2 to the 5th power? I've just even memorized it. It's 32. I don't have to go through in my head over and over and over again. Why? Because that one comes up a lot. Okay, that one's for me, one that comes up a lot. Maybe it's not for you. Let's say it's your friend's email address, because you're emailing them a lot. Well, just memorize it, because, you know, it'll be handy to know. My credit card, I memorized it, because when I'm going on a website and decide to buy something, I don't have to go find it in my wallet. All right, now wait. I know, but don't just put away all your crap and run away. You have to know that I get to end the class, not you. So here's where your homework is. You'll probably want to turn to it on your iPad so that you know which ones are assigned. It's right there. It's that whole page. Now that seems like a million questions, but it's not. It's actually, that's one question. Scribble out the 1. It's never problem 1. It's actually problem 5, and this is just relabeling a drawing for problem 5. And this is another problem, problem 7. And again, do you get how this is a weird looking triangle for a 45, 45, 90? That, just trust that that's actually a 45, 45, 90. And last but not least, that last problem on the page. I went terribly wrong. There we go. Right there. Those 3 questions, that's all you have to do. All right, have a great day.